In Algebra 2, Section 5-6, we're dealing with the remainder in factor theorem. Now, this can be applied from what you've learned about remainders when you learn long division during your elementary years. Basically, we're trying to figure out if polynomials are factors of larger polynomials. And you already know everything on how to do it, like we learned synthetic division or long division in the last section to be able to understand how to find the answer, but this section is just translating what the remainder means. So basically, if I want to know if 7 is a factor of 302, well, let's do the old-fashioned long division. We have 7 on the outside, and then 302. So 7 doesn't go into 3, but it goes into 30. It goes into 34 times. 7 times 4 is 28. Divide by 2, bring down a 2, and then it goes to 3, so 21, remainder 1. Right? So because there's a remainder 1, because of this remainder, it says that it means that 7 is not a factor. So basically, if the factor is 0, that means that the equation is a factor. Now we know if we can use long division and synthetic division, then we're able to find the answer. Now the first part of your section is not about division or synthetic, it's just basically plugging in the numbers for x. So the function of x, so the difference is this is x and this is 6. So just like you learned in the last section, I'm going to take 6, I'm going to replace it with all x's. So it's going to be 2, 6 to the 4th, okay? Remember that these powers are only applied to the numbers, so if I get a calculator, (6 to the 4th) so 2 times 1296 minus 5 times 36 plus 8 times 6 is 48 minus 7. So then I'm going to multiply these. Remember, the order of operation is multiplication and powers come before adding and subtracting, left and right. So the order of operations are essential for this. This is 2592 minus 5 times 36 is 180. And I'm going to bring everything else down. And then, according to operations, I'm going to add and subtract from left to right. So first I'm going to do this. 592 minus 2412 plus 48 minus 7. I'm going to add 48. 2460 minus 7. This gives me 2,453. So, go ahead and pause and write this down. This is just to get you started on understanding polynomials and using the function and translating what that means. Basically, I replace the variable with whatever's inside the parentheses of the function, but I don't do anything to the function, okay? To the sign. This is just to illustrate the function. So f of x equals f of 6 equals 2,453. Now pause it, write it down, and then we're going to start going into using the remainder and factor theorem. So this one is asking, determine whether x minus 3 is a factor of the equation x cubed plus 4x squared minus 15x minus 18. Then find the remaining factors. So first I have to see if this is a factor of this. So I'm going to take this and I'm going to divide it. So it's going to look like plus 4x squared minus 15x minus 18. And I'm going to divide it by x minus 3. Okay? If my remainder is 0, that means that it is a factor. And then I'm going to continue to factor until I have equations that can't be factored anymore. For example, this can't be factored anymore because this is as simplified as it can get. If my remainder is not 0, it's something else, and that means it's not a factor and I can't continue factoring. So I'm going to use synthetic division. So I have 3, 2, 1, 0, so I don't need to put any zeros, and this is a negative 3. There's no number from the x, so that's why I'm going to use this. So the synthetic division is easy. It's positive, right, because this is negative, so I use positive. 1, 4, negative 15, negative 18. So I'm going to take this and bring it down, and I am adding on this one because I subtract for long division. 1 times 3 is 3, 7. 7 times 3 is 21. This gives me positive 6. And then 3 times 3, 6 is 36. So we have positive 18, I think. So my equation would be x, I'll start with 1, so it's 7x squared minus 15x, sorry, it's x squared plus 7x plus 6, and the remainder 18 over x minus 3. Because of this, we state that it's not a factor. Okay, and because it's not a factor, then I can't continue factoring it out because the remainder is not 0. So go ahead and try this. In class, we'll probably go over an example, one of these two, where the remainder is a 0, and I'll show you how to factor it more. But basically, if you're not doing any new concepts, then last section, you're just translating what a remainder means. We can't go further. We can't factor this because this multiplied by another polynomial cannot get this because we have our remainder. So go ahead and pause, write this down, and I will see you in class.